So John, yeah, John's mentioned, I forgot last time to talk to you guys at the end of class, which I meant to do. Um, so there's supposed to be a second midterm, right, for this class, but we're pretty much rapidly approaching I think it was supposed to be like next week.
Mhm.
So I'm thinking of doing something a little different. And in quantum, what we did was, and John, you can correct me if I've forgotten this already, but what we did was we decided to do, everybody does, so I assign a problem to everybody, or a different problem for each person, and we do presentations on that problem as the midterm. And then also assign problems that don't have solutions for extra credit, right?
Mm-hmm.
Is that right, John? Is that what we thought of? And does that sound right?
Yeah.
Was there any other component that I'm missing here that I didn't say?
No, I don't think so.
Oh yeah. So okay, good. I'm glad you remember. So what do you guys think about that?
That's fun.
I'm okay with it.
Yeah.
Sounds
I've got the
good.
stylus and everything, so I can
What
do
was
it.
that?
I got the stylus and everything, so I got that.
Yeah. So someone was also talking about well, how do we do that if we don't have like a board? But you can write your solution on a piece of paper, right?
Yeah.
And take pictures of it, and then as you present, you can show the PDF, right? You know, like, do you know what I mean?
Okay, yeah, I can do that then.
Yeah. You don't need to actually write on like a whiteboard like Joe does.
Wait, so when you would take pictures, save it as a PDF,
Yeah.
is there a way to show the PDF on here? Oh wait, no, never mind.
Yeah. Yeah.
Screen
Yeah.
share. I
Screen
forgot that was
share.
like a whole function thing.
No.
I was thinking it was just the camera thing, and I was like, yep.
No, that wouldn't work as well. It would work probably, but not as well, right?
All right, never mind. Just dumb.
So we're thinking about maybe next week. I'll assign problems this week, have them start to be presented next week. And the issue is, I think that we were thinking about is just we probably could do it all in one day, right? Yeah. I think it's not like they're going to be that long. I'm saying so. So I think we could do them all in one day, and then, but in quantum, I think we were thinking of doing it differently, but I can't remember. I think we were thinking of doing different days for different people, but that gives more time to people. You know what I'm saying? You know what I mean? If you're later, you have more time. I don't know. It's not that fair. So sound good? Maybe we can just all do in one day. Yeah. Bill, did you have?
I mean, that's like almost 5 people or 5 minutes per person.
Yeah.
So you have only one problems and one extra grade problem. So how are you gonna grade it? Are you gonna?
I'm sorry. What?
How are you gonna grade it?
The presentation.
Yeah.
Oh, just did you get the problem right? Did you present it clearly? Did your method, make sense? All those things.
Okay.
Does that make sense?
For the extra credit, are they just doing problems? It's not presenting the problems?
No, it's like doing problems, but they won't have solutions.
Okay.
So these are more like, you got to put some time in to really figure out how to do them. Like I said, I think it's very, very valuable to have solutions, right? So, and that's why we give solutions out for homeworks, before you do them. But I think it's also good to try to challenge yourself. It's kind of like a test, right? But it's not a test, and it's extra credit, these problems, right? Yeah. And then of course the final is going to be like open book and everything, kind of like a take home.
Gotcha.
And you just can't use another human.
Right.
And then, in general, usually take homes, you can't use the internet, right?
Right.
So as well.
Other than to submit it and stuff.
Huh?
Other than
to submit it, yeah. And then obviously to download it, because you're not going to get a paper copy yet.
Right.
Yeah. Does that sound like a plan?
Yeah, that sounds good.
Okay. Any other comments?
Roughly, how long are we going to have to prepare these problems and so forth? Is it going to be like a week?
That's a good question. Yeah, I would say a week. So let's say I get them on Friday.
Right.
And then you would present. We could try to all do it one day, right? Could do that, couldn't we?
It's possible.
Yeah.
And then you present the next Friday.
Oh.
Would that work?
Sure.
Yeah.
That's solid.
What was that, Bill?
That sounds solid.
Okay, good. Where are the rest of our gang? Are they here yet? Or? Oh, there we go. There's Jeff and Scales, but I don't see Tenzin.
Tenzin's probably working on eLab.
Oh, really? So what are you guys doing with that?
So we're using Multisim Online.
Oh, yeah.
And that works for this lab and the next lab. And then after that, Sheldon's kind of like, well, I can mail you all Arduinos.
Oh, yeah. Right. Okay. Right. And did you guys have something to do today?
Yeah,
Gotcha.
I got an extension, but
Okay.
because Sheldon does not answer his emails at a reasonable hour.
What?
He sent me an email saying, "Sorry, I couldn't get to this today" at like 3:04 a.m. I'm like,
So
"What
just
are you doing?"
so if you want the fastest response, you email at 2 a.m.
There you go.
Yeah,
I mean, set an alarm. Come on. What's wrong with you?
yeah.
Night shift.
Well, I emailed him at 4 a.m, so
Jeez.
I got the email about Symposium of Artists and Scholars, and I was like, why can't this be live? Did you guys see that email?
Yeah.
I don't think I've seen that yet. What was the?
I'm fine with it being like on just like a pre-made thing, but I think then you can't have questions, right? So
I mean,
Yeah, I
AAS.
was like, what? Maybe there's some reason that they don't. I don't know, but
I know AAS is going to a virtual conference. I don't know what.
Yeah. yeah, I feel like why couldn't I emailed him? I don't know if he hasn't got back to me, but like maybe it was just too much work and there's no one to do it because there's everybody's so overloaded right now.
yeah.
Maybe they was just like, we just can't deal with that. That's too much. It's crazy. Because
And
you
also
have to organize it all, and like everybody would have to, your internet connection have to work so that you're not like, you know what I'm saying. There'd be all kinds of issues, but I think it would have been fun because you could have had different rooms, Zoom rooms, right? Different Zoom IDs or something.
Yeah.
Whatever. And so that people could just be like, I'm going to this room to see these talks, and I'm going to this other room to see these other talks, right?
Yeah.
And you could have questions and everything from the audience.
Mm-hmm.
I don't know. I know that would have taken a lot of work to organize.
I still think they're going to try to do questions, but it's going to be like on the posted video that you post.
Yeah.
But that's
Yeah.
still, you know,
But it's
It's-
like, how do you even respond? I don't know. I don't know. I don't understand. But anyway, just take a look at those of you who are presenting. I know, Joe, you were going to present.
Yeah.
So see what you think. I don't, but I'll see what he says. But I think that decision's been made because he sent the email out.
Mhm.
You know? Anyway.
When was the symposium again? It's like 2 weeks from now, 3 weeks from now.
Yeah, it's the end of April.
Okay.
23rd and 24th.
Okay.
Like right at the end of school. Anyway, let's get back to work. So let's see. I am recording. Thank you for that. I'm going to share screen. Okay, so this is where we were last time, right? We were looking at finding the magnetic fields at a point above an infinite line of current using the Biot-Savart law, right?
Yep.
Okay. And we were looking at, just we said we want the magnetic field at a point S above the line, right? Or point P, sorry, S distance above the line. Here's omega, here's dl prime, I'm just saying that this distance from here to here is L, right? I mean, you could have called it X. I can't remember who called it X, but somebody did. Joe, I think. Could have called it X, sure. But anyway. And then we looked at what is the direction, right, of the magnetic field, and that's given by the direction of this cross product, right? So again, you're gonna, this is the way I do it anyway, curl, put your hand in the direction of dl prime, curl, all, towards omega hat, which is the same direction as omega, and then you're out of the board, right hand rule. And then we said, what is the magnitude of dl prime cross omega? And we said, we can just use the good old good old 1/16 version of cross product, right? Of the magnitude of the cross product, that is.
Yep.
DL prime, the magnitude of omega hat, which is 1, and then times sine of alpha, which is this angle between the two of those, yeah?
Mm-hmm.
Okay.
Yeah.
Okay, so we've got the magnitude. We need to figure out what the magnitude is of DL prime, right, in terms of stuff. So would be great if we knew it in terms of, things like S, etc. Right?
Yeah.
So first I'm going to figure out what is L prime. So I'm going to go like, what is L prime? So let's define another angle up here. Let's call it theta, just for ease. So what is L prime in terms of theta?
The
What do you think? Think about it. I gotta yell at Finn. Hey, Finn! Finn! Turn that down or use headphones.
Is it sine theta omega?
Sine theta omega. Okay, yeah, you could do that. Let's see if we can find, like, I just want only S in there. Can I do that?
Cosine, yeah. That tangent.
Yeah, sure. So L prime equal S tangent theta. Right? Okay. I mean, I could have used omega. You're right. Okay. Now, if I do that, I can get DL prime, right? What do I do for that? S doesn't change. So I just need to take the derivative of the tangent.
So secant squared theta d theta?
Sure. So I'll just write that as 1 over cosine squared because I hate secant. Hate it. D theta. So that sounds good?
Yep.
So you can see why I didn't want to use omega, right? I don't want to have to take a derivative of omega in here. See what I'm saying?
Yep.
All right. So now I have DL prime. So that's great. Now I have this right now. But the thing is, I have this alpha, right? And I have to deal with that in a second, I guess. Let's see. All right. Well, what about the magnitude of omega? Because I'm going to need that here. Might as well just go. So basically what we have now is I guess we should probably deal with this angle now. Don't you think?
Yeah.
Okay. So how do we get how do we get the angle? Because, so why did I even define this? The reason is that if you think about, like, what are you going to integrate over? It's not going to be alpha, right?
Yep.
When you think about integrating over this, you're going to be like moving theta. This point's going to move down the line, right?
Mm-hmm.
And down this way too. So what would be the limits of integration for theta? So we're going to integrate over theta, right?
Yeah. I guess minus pi over 2 to pi over 2.
Yeah. Yeah, makes sense? Yeah, guys?
Mm-hmm.
All right. So I don't really want alpha hanging around. That's just kind of annoying. So how are we going to get alpha?
Well, you get 90 plus theta.
90 plus theta, that's right? Does that make sense? Just geometry. Yeah. Okay. All right, so alpha is equal to pi over 2, or, doesn't matter, theta plus pi over 2. So this is going to make this a cosine, right? Let's just drive that down here. So we have the magnitude of DL prime cross omega hat is DL prime, but cosine of alpha, right, which is theta plus pi over 2. Sine of alpha, which is sine of theta plus pi over 2, so that's just cosine of theta, yeah?
Yes.
Mhm.
Okay, so let's keep going. So this would be S, and then, because I'm writing now DL, right, here. And then we have one over cosines where our times cosine, so we just get S over cosine theta, d theta. Yeah?
Yep.
All right. What about we gotta get now, so we have this, we need this. So we need the magnitude of omega.
Be s squared, the square root of s squared plus L prime squared. Yes.
Yeah, but you can write it in terms of cosine theta, because I think that's what we're gonna integrate over.
Yeah.
Might as well write it in terms of cosine theta, right?
Yeah.
That's cosine theta. Oh, sorry, the other way
S
around.
squared over cosine root theta.
S equals omega cosine theta, right? So you're right, we could have integrated over something else, right? But we already have theta in here, we might as well keep everything in terms of cosine theta, right? So that means, omega is S over cosine theta, yeah?
Yep.
So omega squared is S squared over cosine squared theta. You good with that?
Yep.
Okay, so let's try to put it all together. So we have this guy. So inside the integral, right, we have dl prime cross omega hat over omega squared. So this is S. Check my algebra, everybody. I hope you're checking because you know how that goes.
Yeah.
And then 1 over this, so that's going to give me the cosine squared on the top over S squared. And then this is going to give me cosine theta over S. So far, so good?
Yep.
D theta? That look right?
Mm-hmm. I think so.
Okay, cool. Is S changing? No, we don't care about S, right? S not changing. Yes?
Yep.
When I put everything in the integral now, so let's go back to B. I'm going to pull S out. This is starting to look familiar, I bet. I hope. Maybe. Okay. And then we're going from minus pi over 2 to pi over 2 of cosine theta d theta. Yeah?
Mhm.
Pretty good? Pretty easy, right?
Yeah.
I mean, getting there wasn't the easiest thing, but. And then we're going to have sine theta. I always forget if it's minus. Is it minus sine?
I think it's plus if it's the
Plus,
anti-derivative.
right? Yeah. Yeah, that's right. Right?
Yeah.
All right. Minus pi over 2 to pi over 2. Right? And so we get mu 0 I over 4 pi s and then times 2, right? This is what this is going to give us. I hope you don't mind me not writing that out. And then mu 0 I, this is now 2 pi s. Does this solution look familiar to you?
Yes.
And I should say right now, this is just the magnitude, right? Because I didn't put the direction in. But right at that point, it's pointing out at you, right?
Mm-hmm.
Isn't it?
Yeah.
Yeah. And what does it actually really look like? How about if I drew, let's think about instead of being, okay, so this is how I would think about it. So think about taking this page, this whole page, right, this whole flat page, and now tilting the whole page this way for the next point,
Mm-hmm.
right? You would still have the B field going perpendicular to my hand this way, right?
Yeah.
You see what I'm saying? So now you're rotating around. I can't do this on like here's the page plane, and then this would be the direction of the magnetic field. So do that with your hand, you can see. If you're going like this, then the direction of the magnetic field is just turning, right? Page plane, direction of magnetic field going straight out your thumb, turning. So what does the B field look like? Like everywhere around the line. What? I didn't hear you. Somebody said something.
Oh, that's probably just yawning.
Okay. But do you understand what I'm doing with my hand? This represents the plane.
Yeah.
Okay, so right now the plane is like this and on your computer screen, and then the field is your thumb, which is, you can't see it, but it's back here.
Yeah.
So, right? And now I'm going to rotate the plane a little bit, and my thumb rotates. Right?
Yeah.
Okay. So what if I was going to actually have that wire sitting like this? What would the field look like around that wire at all points that I just rotated around?
Okay. Curling around.
Yeah, going around. That's right. So if I draw it like here's the wire coming out of the page. So now this is the eye coming out of the page. Then the B field will look like, rings. Right?
Mm-hmm.
Right. And then
As the wire rotates?
well, okay, so hold on. Let me just draw this. So what I'm saying is, okay, so what I was saying about the rotation is that right now on your screen, right, the plane direction is, the direction of the plane is straight up and down like this, right, on your screen, right? And so right now, your B field is like my thumb coming, right, so like this. B field coming straight out at you. Now, to figure out what it looks like at a different point, so here's the wire. So think of my pen as the wire. Okay, the plane is like this, right? We're looking at a point right here, and the B field's pointing towards me. But now if I move to a point that's slightly over here, and I'm trying to go all the way around the wire, right? That's like taking my finger and rotating it a little bit so that it's no longer vertical. But my thumb is still in the direction of B, but it's sort of pointing down at me now. Right?
Yeah.
And if I rotate it all the way so that like the plane is like this, then my thumb is going to point straight down, right?
Mm-hmm.
So the point is that if you can visualize that, it's pretty hard to do. You can see that the B field looks more like a circle around this wire. So now the wire is pointing out at you in this view. The wire is coming straight out of the computer, and the B field is going to go around, right? Sort of circling around, and it drops off. The magnitude drops off as 1/s, and so S is now this distance here.
Mm-hmm.
That make sense?
Yeah.
Yeah. So that's and this should look familiar because I'm sure in 116 you guys covered this case, right?
Mm-hmm.
Okay. So I'm pretty sure. I mean, you didn't use the Biot-Savart law, is my guess, although you might have. But this is that thing where you have current coming. If you have current, you curl your hand around the wire. Your thumb is the wire, and you curl your hand around, and the B field is in your finger directions, right?
Mm-hmm.
Yeah. Okay. So it's kind of the circular field. All right. So there should be. Let's see. Yeah, there should be a worksheet on Moodle for you to look at. Can you go look?
Mm-hmm.
More practice with this. I'm going to leave this up because you should think about taking apart the Biot-Savart law the way we just did, right?
Yeah.
So we're doing the Biot-Savart worksheet,
Yeah,
however you
Biot-Savart.
pronounce it.
Biot-Savart. Yeah, it's a weird one.
Biot-Savart.
Yes. I have no tea left. Yeah, so just sort of take it apart the way we've done. you want me to write down the steps?
Yes, please.
Because I didn't do that in the worksheet. I would say, so what do we do first? We looked at the direction. So when we got the direction of B. And this one was really, really simple. This next one here, it's not as simple, but I would think about symmetry before you go nuts doing a bunch of stuff, right? All right, so think about the direction of B. Next thing we got the magnitude of DL prime cross omega hat, okay? And this, I'm condensing some of these things, right? And then we got the, what is omega hat? What is omega, right? And of course, in there we have to determine limits of integration, et cetera.
So when you say on an axis,
Yeah,
so,
should I draw it?
well, so if I have like this ring, this is confusing. If I have this glass, right?
Yeah,
It's anywhere along here.
absolutely.
Cool.
And the rim of the glass is your current loop.
Yeah.
Yeah, you got it.
So is the current going through the line between the loop, right? So the loop doesn't have anything. Is that what you mean?
No. So
Current
so
going
if I were gonna draw it, like I might draw it like this, where you have like, and then this is the meant to be the loop, right? Current coming out, and then you got it, and I just sort of cut the loop, right? I cut it in half, just sort of cut the loop, right? I cut it in half. Oh, that was weird. It's like an echo. You hear that? Somebody's echoing.
Yep. My computer's being dumb right now.
Okay. Might mute yourself.
Yeah, my screen is like freezing, so I can't even mute it.
Mute yourself.
Okay, give
He
me a
can't. His screen is freezing.
I can mute you.
second. Okay, yeah.
Okay, there we go. Okay. All right. So if you think this is kind of like I cut the loop in half, right? And it's bad drawing. I'm really sorry, but like I cut the loop in half. This is the axis. And you're looking for like, here's our point P, what you're after. So first thing is the direction of B, right? And what symmetry can you use, right?
The fact that it's a ring.
Yep.
Okay, I think everything's okay again.
Oh, good. Okay.
So, all right.
I should tell you the radius of the loop. How about big R?
You did.
I did? Oh, good. All right. Don't remember that. All right. once that you can run a meeting while converting the meeting recording.
Huh. That's
So
interesting.
it looks like what I could do is like to have a brief stop in between classes and have it convert.
Okay. That's cool.
Yeah, it's doing it right now. So unless it takes up a bunch of like, computing power or something and makes everything slow down, that would be a bad thing. All right, let me share my screen again, sorry. Okay, back there. You good? See everything?
Yeah.
Good, all right. Hopefully the Ethernet cable will fix some of the problems.
Mhm.
How's it going? You figure out what the direction of B is?
Yep.
Tell me, what is it?
Right out of the middle of the ring.
Yeah.
What the point, right? I mean,
What was that?
is it like yeah. No, the same at left.
Okay.
But now the relationship between alpha and theta is different.
Well, yeah, there's different angles in this, right, that you need to use. Right.
Yeah.
Show me what you've got and can you get an answer?
I think I have an integral set up.
Okay.
It's at the
Okay, what are you integrating over?
I haven't figured that out yet.
Okay. That's
I mean
fine.
the loop, but so it'll be like 2 pi something. But
All right, well, think it through.
is it just using DL would become 2 pi r after you integrated it?
Mm-hmm. Yeah, that's right.
Okay.
What about you, Kyle?
I mean, I'm at the integral part, but
Okay. Joe, are you good?
Yeah, I think so.
Okay.
Oh, hey Shank.
Sorry, that was my fault.
Oh, that's what happened. What happened?
I didn't recognize the name of your device on the Wi-Fi. It was FMAC SC and a bunch of numbers.
Yeah.
It wasn't
Doesn't have a
F
name.
dash
Yeah.
SC. We should have
We should
changed
probably
that.
change that. Yeah, okay.
Okay, sorry about that.
That's all right. Go ahead.
For MATLAB LabVIEW, our homework is requiring information we don't have, and we haven't gone over any of that yet.
What information?
Like file directory stuff.
Yeah, I'm gonna go over that today.
Okay, just making sure.
I think we're gonna drop the second problem in the LabVIEW book.
Okay.
The first one, which is not hard. It shouldn't be hard anyway.
Also, I have worked so hard on getting that quadratic root solver working, and it works like kinda.
Kinda.
I can do the real roots fine, but the imaginary roots sometimes, I don't know why, but the decimal values all come out as 0. So it'll show the imaginary roots is correct, but...
Right. Okay, well, we can take a look at it. Leif, are you done with the first one or no?
Yes, I think so.
Are you going on to the second one?
I am.
Get an answer for the first one. Let me see it, okay?
Oh, okay. It's in the box at the bottom of the page.
Oh, I can't see. Okay. I think you're missing a term. You're missing an R squared up there on the top. Big R squared. Yeah? You can find that?
Never mind. I found it.
Okay, good.
I pulled it out by mistake.
Aha, got you. That's fine. Do I need to draw a picture of the second one?
Sure.
Yeah, I mean, it'd be helpful.
Sure. All right, let me, there's no room. Maybe right. If I move you guys, there's some room. Okay. Right. All right. So we're looking at, wire comes down like this, and then it goes like this into a semicircle, which is a very badly drawn semicircle. Oh, that's not even right. Sorry. Sorry about that. Let me fix. No. Go away. Joe, I think you're echoing again.
Oh.
A little bit. Okay, so I'm very bad at drawing. So it's like down like this, and then like that. Oh, that's terrible. And then there's a center here, right? Center of the loop.
Okay.
Does that sort of make sense?
Mhm.
So the eye is coming down like this, and then around, and then out.
Yeah.
While you guys are working on it, I think I'll try to do a better job of that drawing. Okay. Let's see. Okay, clearly not doing a good job. But
All right. I got part 2.
okay, what you got? Show it. Can't see. What is that? What is that? R?
On the bottom?
Yeah.
Yes, no.
Okay. All right. Cool. Slightly better drawing.
Your efforts are appreciated.
I know we're 1 minute out of class right now, or we're 1 minute till the end of class. Okay. So we will continue this. Okay, for part 2.
On Friday?
And I will be giving you your problems that you will be presenting in a week on Friday.
Cool. All right. See you in LabVIEW.
All right, see you in LabVIEW.
Hey, Dr. Shank.
Yeah.
Is first one mu naught I over 2r I?
2RI.
2r and then an I on the.
No, you need to have the distance in there, right? From the center out to the point.
Right.
What are
Okay.
you calling that?
Say again.
What are you calling the distance from the center of the loop to the point where you're looking for the magnetic field? What is that distance called?
R.
No, R is the radius of the loop.
Okay.
Call it something else.
I get what you're talking about. The point to the
Yeah.
plane of the radius. I called that x.
Okay, so that's gotta be in your, because most likely it's gonna be different. Magnetic field will be different if you're farther out or
Right.
so.
Yeah. I had a different equation, then I tried to simplify it down.
Okay. What did you have first?
I had mu naught I r squared over 2r squared plus x squared to the 3/2.
Yes, that's correct.
And then I was trying to simplify that down.
Oh,
And
I
that's what I was
okay.
trying to put down. But all right.
Good.
I'll see you in 9 minutes.
Okay. See ya.